Yes. Now that's how we are going to define our class dataset for training functions, training dataset. Now, suppose we have a test dataset. How do we load that dataset? So the main key difference between our training dataset and our testing dataset class is going to be that in our training dataset class, we want to expose it to the ground truth, the labels. But for our testing dataset class, we do not want that to happen. So what we're going to basically do is, again, we're going to define our init function. And we're just going to define our x's. We do not want to define our y's at all. We do not want to define our ground truth labels functions at all. So we're going to define our we're going to define our x's, and we're going to define the length again, because it is very important for us to all know the length of our given data set at any point in time. So that's how we define our init function. Then we go on to define our length. We're going to return the length function over here. Yes, and finally, we're going to define our get item function. And out here, we are just going to define our get the item. That's right. That's how we're gonna, guys, define our dataset class and our toy dataset class, or our test dataset class. Now, let's see if we construct and index our dataset that we introduce right now. We will first create an instance of the dataset class, which we just created up in the above cell, and then we're going to check for the length of the dataset class. In the indexing operation, now we will call the get item function, because that's where we've defined how we want to retrieve our data point from a particular index. So say we want to return the first very item. So we're going to index it to 0 and we're going to print out X and Y. Similarly, if you want to pass it through a loop, this is how we're going to pass it through a loop. You can also use the next method. So there are different ways in order to retrieve our data at a particular index. This is a small exercise for you guys so that you guys can also get familiar with how to define your dataset class. Now, an example for a dataset based on the Kaggle data, which you guys will be clearly working with, is that it is divided into three, the directory structure such that it is divided into three folders. There's a training dataset, which has its features and labels. There's a test dataset, which has only its features, and the validation dataset. A validation dataset is definitely very important in our model development. Now, given the structure, we do not expect, but it is preferred to have this kind of a dataset class, which gives you more control over the Kaggle dataset essentially. So it is very important for you all to familiarize yourself with this kind of a function. We again, the structure remains essentially the same. It's just that more processing power and more pre-processing options are given to you guys. Similarly, it's done for the testing data set also. So yes, that's how we will define our training data set, validation data set, and our test data set. Thank you. So this is a small example that we have developed for essentially specifically audio data sets that you guys will be using in your homeworks. So the Kaggle data set, like mentioned before, has the training, testing, and the validation data sets for the audio data set class that you guys are going to be using it for homework part 1, 2. So and first of all, we need to unzip the data set. The data set is going to have your samples and your labels. So if we just load, like say, one sample or a label, we see that the shape of X is 1825, 28, which is essentially the total number of time steps, and 28 defines the number of features for the MFCC file format. Now, as for the transcript of the dataset, it is organized as a 1D array with a length of t plus 2 because we need an SOS and an EOS tokens as well. So the SOS is, as said, located at the start of the transcript and EOS at the end of the transcript. For homework one, these two tokens are not needed, so you might want to remove them from your pre-processing pipeline. But yes, essentially, it is going to be used in your further homeworks. So if we see the shape of Y, it's 1827. Like we said, it has SOS and EOS, so it's going to be two more than that. And this is how some of the elements of Y actually look like. This is how your transcript is actually looks like. So some of the context information, like we need some proper management of local context and essential to homework one, in which we are actually predicting the phoneme for each of the time step. So the dominant solution in the past was like we handcraft context, but now in this homework, we're going to actually apply context windows. So context windows adds a local context by simply concatenating multiple consecutive time steps. The result is a big feature vector that is better aware of the local information. So say we have like our x64 and y65. We are offsetting the y because we want to ignore the SOS token. So this is how our x and y look like. Our x is of shape 28 because like we said before, we need particular it defines the number of features in the MFCC dataset. Now, if you want to apply a context window of say 10 to the at the 64th time step, like we see here, this could be done by concatenating 10 features from 10 from the past and 10 from the future time steps. This is super important to understand. So say we have at the 64th time step, we want 10 from before and 10 of the future frames. So after concatenating our context, the shape of X will look something like 21, 28. Now, since we're defining an MLP network, we need to flatten it. So we essentially just flatten the entire data set and then we use it in our MLP model. Now, it is very important to visualize the data set. So this is how our data point actually looks like. This is with the context window, like we said, 10, 10 or the past and 10 for the future. And this is how our data set looks like. Thank you very much.